So in this video, we're going to talk about graphing radical functions. And so you can see here that we have a square root of x. This is what it looks like. We've talked about that in the last video. But, it looks like a sideways parabola. In fact, let's real quick graph a parabola here. So you can see that, and if we throw in the line y equals x, you can see that that's a reflection across, especially if we zoom out a little bit. You can see that the red line is a reflection across the green line. So that reminds us of that inverse relationship we were talking about before. So in general, when you're graphing a square root, something with a square root in it, you're thinking about basically what I think about is a sideways half of a parabola. So that's what the just y equals x looks like, or y equals square root of x. So, and of course, you can always graph things by plugging in x values and getting out y values, but it's helpful to kind of know what you're looking for. So we're kind of looking for this. It's not really a vertex, but it's like a vertex where kind of the beginning of this swoosh begins. So let's look at a couple examples. So if I graph y equals, let me stick this back in a little bit. Y equals the square root of x minus 2. Notice that it looks exactly the same. It's just been moved over to the right 2. And then if we do square root of x plus 3, and let's make this smaller so you can see it. Again, the same thing, looks the same shape, but it's been moved to the left 3. And then notice if we do the same thing, like adding and subtracting the outside, why do you keep moving on me? Let's clear that out for a minute so you can see that it's just moving it up and down. So the purple one is the same as the red one, only it's been moved down 2. And I think it's black. The black one has been moved up 1. And notice if we change that, of course, back up, put a 3 in there, it just moves it up even further. So if we go back to something we talked about a long time ago in parabolas, notice that this affects vertically where that endpoint is, and those affect horizontally where the endpoint is. And notice this endpoint, or beginning point, if you will, is located on the x-axis where whatever makes the inside of that square root 0. So if I plug a 2 in there, notice this becomes 0. If I plug a negative 3 in there, that becomes 0. So that tells you where that's at. And then, so if we take this and put a plus 1, plus 2, let's say, okay? So notice that it moves it to the right 2 and up 2. Or if we make that a plus 3, or if we switch this in here to a minus 1, you can see that it's just, we can move that same shape around wherever we want to. Okay? So that's what adding and subtracting does in the equation. If we go down to multiplication, notice it doesn't change where that beginning point is, but it makes it steeper. And of course, if we multiply by 1/2, it makes it less steep. So it's good to have this idea of what the different things in the equation do before you go into graph it. And you can still just plot some points, but it makes it, you're able to get to the point you want quicker. So for example, if I go over here and I want to graph y equals the square root of x plus 2, and we'll start off with a simple one. So I'm thinking, based on what I just saw, that negative 2 makes the inside 0, so that makes me think that that little kind of quote-unquote vertex is not really a vertex, but would begin right here because it hasn't been, there's nothing added on the outside. And so then I could start off, if I wanted to, plotting a few points. So I know that, for example, negative 2 is 0, got that. And if I go over 1, negative 1 would be 1, because I put a negative 1 there, I get square root of 1. So I know that's right there. And I can see that half of a parabola begin to grow. I know also that if I plug in, not 4, if I plug in 2, 2 plus 2 is 4, square root of 4 is 2. So if I go over 1, 2, up 2, and you can see, and now because I've seen a bunch of these, I know that's pretty much what it looks like. I don't have to do any more point plotting. So notice if we would have just went in blind, we might have been plugging in points for a while before we begin to see any kind of a shape. So again, if we did another quick one, if you do, let's say 2 times the square root of, we'll just do 2 times the square root of x plus 3. Okay, so again, if I'm trying to graph that, I know that that beginning, you know, the beginning point is going to be at 0, 3. 1, 2, 3. Oops. Because the inside of the square root is 0. And I'm adding 3 on the outside. So I know it's got a beginning going to go like that. So then I'm just going to draw my little table over here and go x f of x. So I just plugged in 0 and got 3. Then I'm going to plug in 1, because I can take the square root of 1. Square root of 1 is 1. 2 times 1 is 2. 2 plus 3 is 5. So I know from here I'm going to go over 1, up 1, 2, 3, 4, 5. And I can see the beginning of that swish. Another point that I want to plug in is 4, because the square root of 4 is 2. 2 times 2 is 4, plus 3 is 7. So that means if I go over 1, 2, 3, 4, I go up 1, 2, 3, 4, 5, 6, 7. And again, I'm not surprised by the shape of it because I expected it to look like a sideways parabola. You can see that other half going on there. Okay, so that's graphing radical functions. Now if we switch back here real quick, what if instead of a square root, we had some other root? Well, that's a good question. I'm glad you asked that. Remember, we know how to do roots now. We can just go x to the, and I'm going to put, say, 0.25. So that would be the same thing as a fourth root, right? Because that's 1/4. And you can see what happens. It looks kind of like the square root function. In fact, let's put the square root function back in there. Okay, so it looks kind of like a square root function. It's just steeper at the beginning and less steep afterwards. So it jumps up real fast and then goes, graduals out. So it changes the shape of it a little bit, but it still has that same basic, you have a beginning point and it grows, it looks like a half of a, well, it looks like a half of a sideways fourth degree. So, but another thing that's interesting is what if we change this to 0.2, which would be like 1/5, okay? You can see that now we can go both ways, because if you take the fifth root of a negative number, you can get a negative answer. Whereas if you take the fourth root of a negative number, it doesn't produce anything. So again, that's x to the 0.2, or 1/5 power. So you can see that it looks like, so anything that's an odd root it's going to have a flip on both sides, and anything that's a even root is just going to have a one swish sort of thing. And this, of course, we already kind of expected this because we've already graphed polynomials, and you remember that with a polynomial, when you have a fifth power, like x to the fifth, again, it just looks like that. And so, and just to remind us, because we're talking about inverses here, there's that line y equals x, and you can see that, let's change the color of that. Why don't you give me a different color? See if it'll give me a different color down here. There we go. Yeah. I might give me the same color twice. Okay, so notice the green is the x to the fifth, and the red is the x to the 1/5, or the fifth root. All right, so that's graphing. Now we can get real funky if we do something like this. Let's clear those other ones out. So if we have a rational, so that would be a cube root, but also squared. And so you can see because of the squared, it never goes positive. So it's kind of like the cube root, but because of that squaring, it makes it a little bit, it changes the steepness of it, but it also flips it over to the other side because of the square. I can never have positive y values. So that's kind of a fun one. But so the main idea is to, when you're graphing these, is look for that key point and plot that first, and then just plot some points around it. All right.